Okay, so remember that the z objective function is the function 3x1 plus 5x2, and then we have this inequalities or the functional constraints, non-negativity constraints. Having that general LP, standard LP, we write the corresponding slack form. What's the slack form? Well, for each functional constraint, you introduce a new slack variable and transform each inequality into an equality. That's the slack form. And all the variables, including the slack variables, would be non-negative. After that, what do? You designate some variables to be basic variables, and you designate some variables to be non or co-basic variables, or independent variables, whichever you like. And then you write down your first dictionary. The first dictionary means you look at the functional constraints, and from the functional constraints, I'm looking into the slack form now. Look at the functional constraints in the slack form, solve for the basic variables in terms of the non-basic variables, and you are going to get your initial dictionary. Now, usually, like I said, in our initial dictionary, we designate the slack variables to be the basic variables, and the remaining ones would be the non-basic variables, right? How many basic? Exactly the same as the number of functional constraints, and that's what we have. We also write the z, the objective function, as the last row of the dictionary. So we have that set up. Now, remember how we got from one dictionary to another? We have to identify an entering variable, identify a leaving variable, and then we do pivoting to rewrite our dictionary in terms of the new basic variables, right? So what are you changing each time? You are changing the basis, right? Basis means the collection of basic variables. You're changing the basis, but how are you changing the basis? Well, each time only you are taking out one of the basic variables and putting in one of the non-basic as a basic, right? So the only in the basis only one variable is changing, right? You keep all the others the same. Only one variable in the basis is changing, nothing else. In any case, you know how we can find an entering variable. What's the test for choosing an entering variable? What's the test for choosing a leaving variable? I'm not going to go over that again. But then once you choose them, right? So remember, we chose x1. We chose x1 to be the entering variable, and then we said x3 would be the leaving variable. And once I have chosen my entering and leaving, then what did I do? I look at the constraint corresponding to the leaving variable. Which constraint corresponds to the leaving variable? The first one. I look at that one. I solve for the entering variable, right? I solve for the entering variable, and then in the remaining constraints, I replace the entering variable by the expression I get for that from the constraint where I have the leaving variable, right? Am I making sense? Okay, I think that was a little too wordy, but I hope you got what I said. Now, so what I said is a little bit too wordy. That's why I decided to say what I said in a little bit differently. So what I want to say is that going from this dictionary to the next, this is what you are actually doing. What you're doing is that you are applying row operation. Remember, for matrices we have row operations. So when you have this dictionary, think of this dictionary as a matrix, okay? A matrix with the coefficients of the variables, right? Am I making sense? Now, what you're doing is basically, once you have the basic and the you have chosen an entering variable, leaving variable. If I have chosen an entering variable, right, and the column corresponding to the entering variable, I'm going to call that my pivot column. Okay, so here's what I mean. You see this column that I have right here, I am going to call that my pivot column. The column corresponding to the entering variable. What does it contain? It basically contains all the coefficients of the entering variable, right? The coefficients of entering variable. That's what I want to concentrate on. The coefficients of the entering variable. That's my pivot column. And then, what's the pivot row? Well, I have a leaving variable x3, right? I have a leaving variable x3. The row corresponding to the leaving variable, that's my pivot row. So what is my pivot row? My pivot row is right here. Is everybody clear? That's my pivot row. The row corresponding to the leaving variable. Is everybody clear? Now, what is the pivot operation now that I need to do to go to the next dictionary? Well, concentrate on the so now, the pivot row, pivot column, there is an intersection, right? The entry at the intersection, I'm going to call that the pivot. Okay? You guys clear? Look at the pivot row, look at the pivot column. The entry at the intersection, that's going to be called the pivot. Or you can call it the pivot coefficient if you want to. That is, I'm concentrating on the coefficient of x1. It's, what is it? What is it? -1, right? So what I'm going to do, I'm going to make it +1. How can I make it +1? Divide both sides by the coefficient. Now, it may not be -1 in another situation, right? It may be 2, it may be -2, -2, -4, right? Am I making sense? So what I'm going to do is that I'm going to divide that pivot row by the coefficient. Divide the pivot row by the coefficient of the entering variable. Then the coefficient of the entering variable will become 1. That means that the pivot will become 1. Am I making sense? Once I have that, notice that what I'm going to do is that once I have that pivot 1, I am going to now use the pivot row. By using the elementary row operations, I am going to make all the coefficients in the other rows for the entering variable 0. Am I making sense? I'm going to use the word annihilate the coefficients of the entering variable in the other equations. When I say annihilate the coefficients of the entering variable in all the other equations except for the pivot row, what I mean by annihilate, I mean reduce to 0. Am I making sense? So, how do I, this is already 0. In the second equation, the coefficient of x1 is already 0. I have nothing to do. What should I do to make this guy 0? Well, I'm going to multiply this guy by, remember, I'm going to make this guy +1 first. And then I have to multiply this guy by 3 and then add it to this guy. And that's going to make that coefficient 0, right? That's the elementary row operation. Multiply a row by something and add it to another row and replace that row, right? That's the row operation. So my point is, we are going to apply elementary row operations in order to annihilate the coefficients of the entering variable in all the rows except for the pivot row. Am I making sense? And if you do that, you automatically get into the next dictionary. Is everybody cool with that? How's that? Well, let's let's do an exercise and make sure that we see why that's the case. So my first dictionary, what was that? I just wanted to make sure that you understand the way I'm describing the same pivot operation in a little bit differently. And the reason I'm doing that is because I think that's a more clear explanation of what's going on. So with pivoting. So here was our table, our first dictionary, initial dictionary. X3 is 4 minus x1 plus 0x2. X4 is 12. By the way, can someone remind me to give your exams back in the last 5 minutes? Okay, 12 plus 0x1 minus 2x2, and x5 is 0. Not 0. Sorry, x5 is 18. 18 minus 3x1 minus 2x2. Please feel comfortable to ask me questions. There are at times I'm going to say very wordy things, okay, and it may not make sense, so just ask me, okay. And then this is z, which is 0 plus 3x1 plus 5x2. Everything that we are going to do are pretty easy, but that doesn't mean it's always going to make sense right away, okay. And you have to understand that simplex is a very very powerful algorithm because it has been used extensively in many areas, okay. Not just by engineers, companies trying to make their operations more efficient. If you think about, a lot of the things actually came out after World War II, which is a little bit cynical part of it, but it's like a lot of things came out because the the U.S. Army and other operations, they wanted to make sure they are optimizing their operations. Am I making sense? You think about a specific operations that they have. Maybe it's about sending food to the troops, sending this and that resources for the troops. What's the most efficient way of doing that? Things like that. And actually, a lot of the things actually came out of and a lot of the funding for those studies came out of the defense sector, I think. So, in any case, I don't want to say too much about things that I don't know a whole lot about. But this is where it came from. Okay. In any case, this is the initial dictionary, and I want to go to the next dictionary by saying what I said now. Okay, the new way of describing it. And you're going to see that I'm going to get the same answer. So again, you identify the entering variable and identify the pivot column. So what's the pivot column here? Let me highlight the pivot column. The pivot column, basically it's actually not even the x1, it's the coefficients of x1. And then I'm going to look at the pivot row. Pivot row means it's the row corresponding to the leaving variable. Everybody's clear? So what is the entry at the intersection? That's my pivot. The pivot is at the intersection. What is that? -1. So what I'm going to do is that, if you don't mind, I'm going to right now make this a +1. Okay, make this a +1. In this case, you really don't have to. But what I'm trying to describe is that usually you want to divide the pivot row by the coefficient of the entering variable. Divide the pivot row by the coefficient of the entering variable. That's what I'm doing. If I do that, I get negative here, and negative, well, this is still going to be 0, right? Am I making sense? However, in this case, because it's negative 1, I really don't have to do it. And so I won't do it. Is that making sense? I can work with negative 1 very easily. Okay, now my goal would be the following. No, actually, I am going to do that. Sorry. Let me take that back. I'm going to do that. Negative 1, negative this, and 0x2, so I don't have to worry about that. This would be a plus now. Now, I want to make all the entries in the pivot column. I want to annihilate all the entries of the pivot column, except for the pivot that I have. Is that okay? So how do I annihilate all the other entries? Again, annihilate means reduce to 0. Now, already the second entry is 0, so I don't have to worry about that. How do I reduce the third entry to 0? And also the entry in the last row for z, I want to make that 0 as well. How do I do that? Well, multiply the first row by what? Multiply the first row by... So let me write that down again here. So this is not going to be my next dictionary yet. So my first row looks like the following now. Negative x3 is equal to negative 4 plus x1 plus 0x2. My second row will remain the same because it's already 0 there, so I don't have to worry about doing anything with it. So x4 would be 12 plus 0x1 minus 2x2. Okay, now what should I do? What row operation should I do to make the last entry 0 in the third row? Well, I multiply the first equation by what? 3 added to the third row. So if I multiply the first one and add it to the third row, what do I get for x5? Anyone? What do I get for x5? I am multiplying the first row. I am multiplying the first row by what? 3. So on the left hand side, what am I going to get? Negative 3x3, right? So let's write negative 3x3, and then I'm going to add it to the last row, right? And then negative 4 times 3 is negative 12 plus 18. What is that? 6. This will become 0, of course, because that's the goal. And then I'm going to multiply 0x2 by 3, add it to negative 2x2. Will that have any effect? No. And how about z? How about 0? What should I do? I should multiply the first row by what? Negative 3, add it to the 0. And if I do that, I get positive 3x3 plus z. This is equal to what? What's going to happen? Multiplying negative 4 by what? Negative 3, which is positive 12, plus 0 would be 12. This would be 0x1. And what am I getting here? I'm getting 5x2 again, right? If I do that operation. You guys agree with that? Agree with that? Okay. Now, of course, do I need to write 0x1 here? I'm not going to write this x1. Do I need to write this 0x1 here? This is just 0. This is 0. This is 0. All of them. My goal was to get rid of x1 from the right hand side. Instead, what I'm going to do is replace in the third equation. I'm going to send the 3x3 here. I'm going to send the 3x3 here and then delete this. Delete this. In the 0, I am going to make this negative 3x3, right? make this negative 3x3. You guys agree with that? And delete this 3x3 here. I can do that. Subtracting 3x3. In the second row, I can just write 0x3, right? Nothing changes. It's still 0. The first equation, what I'm going to do is I'm going to solve for x1. Am I making sense? If I solve for x1 from the first equation, what do I get? What do I get? I'm going to get x1 is equal to what? 4 minus x3 plus 0x2 still, right? You see that? So from the first equation, I am going to solve for x1. And if I do that, I am going to get 4 minus, not minus, plus x3, right? Plus 0x2. Am I making sense? Is it the same? Is it the same dictionary I had before? You bet, right? If you look into your notes, you'll see that this is the same dictionary I got before. So I just described the pivoting operation in a little bit differently. And I think this is a nice way of describing the pivoting operation. Am I making sense? And I'm going to say again what the pivoting operation is generally in a second. Was I able to express to you what pivoting operation is? Pivot row, pivot column, identify the pivot, divide the pivot row by the pivot, make the coefficient 1 for the pivot, and then annihilate all the entries of the pivot column except for the pivot row. Right? Once you have done that, you got your new dictionary. Okay, but you have to do a little bit of work where you have to sort of express the entering variable from the pivot row in terms of the leading variable, right? Everybody's cool with that? Now, let me go back and sort of tell you how your textbook is expressing, because some of you might be reading the textbook instead of concentrating on my lectures, which is fine with me as long as you keep up with the material. So I want to point to you so that you don't get confused when you read the book, how the book is representing the dictionary. So let's go. So remember the first dictionary that I have? The first dictionary? Your book's first dictionary is this. It's an array or a table, whatever you want to call it. Okay? And I am calling it the array notation for the dictionary. What is it? Well, you have all the variables listed. And below each variable, you have the coefficients of the variables in each equation. Do you have the first dictionary in front of you? First dictionary in front of you? Now, imagine we have 4 equations there, right? 4 equations. Write each of the equations as something equals to the constant term. Am I making sense? Put all the variables on the left hand side, and on the right hand side keep only the constants. So maybe let me go up a little bit. This is the first dictionary, right? What I'm saying is that rewrite the first dictionary where you're going to write all the variable terms on the left. On the right hand side, you only keep the constants. Okay? If you do that, you'll see that you get these coefficients. Think of all the constraints in terms of all the variables. So if a variable doesn't appear in an equation, its coefficient will be 0. Am I making sense? So the first dictionary, if I go back to that again, the first equation there, if I rewrite, I'm going to rewrite this as x1 plus 0x2 plus x3 is equal to 4. You agree? Again, x1 plus 0x2 plus x3 is equal to 4. However, I'm going to imagine that the coefficient of x4 is 0, the coefficient of x5 is 0. You guys see what I'm saying? Is everybody okay? So what I'm saying is that the first, maybe let me write it down here. The first, in my first dictionary, I'm going to rewrite the first equation this way. I have x3 is equal to 4 minus x1 plus 0 x2, right? And I'm going to rewrite this as x1 plus 0x2 plus x3. I don't have x4, but I'm going to write 0x4 plus 0x5 is equal to 4. So I'm going to rewrite that in this way. And if you look at my first row in my array notation, I exactly have those coefficients, right? The coefficient of x1 is 1, coefficient for, so I have 1 0 1 0 0 4, 1 0 1 0 0 4, right? Am I making sense? You understand where the table is coming from. So you write down the table that way. Right side means the right sides of the equations. Basis, because now if I write it in this area notation, I have to keep in mind what is my basis, right? Well, what's the basis? The basis right now is x3, x4, x5. I can tell from the table what is the basis. How? Basis means the variables for which there is only one non-zero entry below that, and that is 1. So look at x3 is the basis variable. Look at, there is only one non-zero entry below that variable, right? And that the non-zero entry is 1. Same thing here, same thing here. Is that okay? That's how I know which ones are the basic variables. And of course, you also have the the equation for the objective function can be written in this way. Now that notice that this is -3, -5 because I am putting everything on the left hand side. When I try to put everything on the left hand side, remember z is 3x1 plus 5x2, but then I'm going to write all the variables on the left hand side, and they will become -3x1, -5x2, and that's why I'm getting -3 and -5. Is that okay? Is everybody okay with what I said? Now I am thinking of z as a variable as well in my work now. I'm also thinking of z as a variable. Okay. You can think of z as a basic variable which is never going to leave. Okay. So that's how your book is representing the dictionary, and I think you would agree that it's a little less intuitive in terms of what you're doing. But my question to you, looking at this table, how is your text identifying the entering variable and the leaving variable? My test for entering variable will be now what in terms of this array? How did we choose an entering variable before? Anyone? How did I choose an entering variable? How did you choose an entering variable? Look at the row for z. Look at the variables with positive coefficients, right? And pick one of them, right? Now, would that same thing work anymore? Now what did I do? Right, remember now, I had 3x1 plus 5x2, but I wrote them on the left-hand side. And when I did that, the coefficients became negative. Now my test should be what? From the 0, the row corresponding to z, that is the last row, identify the numbers which are negative, right? And you can pick the variable corresponding to any one of them as the entering, right? So I look at the 0, I see -3, -5, and what variables correspond to -3, -5, x1 and x2. Any one of them could be the entering variable. Remember, we chose x1 to be the entering variable, right? So your book calls that, your book is calling that column for x1 the pivot column, okay? So this is the pivot column. Now how do you decide on the leaving variable now? How do you know which one is the leaving variable? How do you check leaving variable? Remember, we are increasing x1, and which of the variables come to 0 first? And I showed you how to do that before in a different way, but it comes down to the following. Look at the pivot column, and look at only the positive numbers there. Which ones are the positive numbers there? Well, 1 and 3, right? Now divide the corresponding right hand side. So I said look at the ratios here, right? Ratios. What I mean is that divide the right hand side by the positive entry of the pivot column. So divide 4 by 1, what do I get? 4. That's what I mean by the ratio. Ratio of the right hand side to the entries of the pivot column. And this one I don't do anything because the entry here is 0. And the last one, I divide 18 by 3, I get what? 6. Which one is smallest? 4. So the row corresponding to 4 will be the pivot row. Is that making sense? Let me just end here. This is the pivot row. What's the pivot entry then? 1. And then what? Then what should I do? Well, now do elementary row operations using the pivot entry, and make all the annihilate the entries of the pivot column except for the pivot. Annihilate the entries of the pivot column except for the pivot, and if you do that, you're going to get your next table, which is what I got here. So what did I do? I multiplied the first row by -3 added to the third row. I multiplied the first row by +3 added to the fourth row, and if I do that, this is what I end up with. Okay? This is what I end up with. And if you look at the corresponding dictionary, the way we are writing dictionary, if you look at that, you will see that we got exactly the same thing. Am I making sense? There is a little bit of thinking that is needed from you to see how these things are corresponding to each other. Okay? But that's how your book is... oh, did I forget to write the right-hand side when I did that? I guess I did. The right-hand side should be 4, 12, and 6 here, and 12 here for the 0. Okay. I didn't give you this tables in my handout today, but that's what we have. Is everybody okay with that? So our first dictionary is this one, right? This is how we wrote the dictionary, but we actually wrote what? X3 is equal to the rest, right? So I rewrote my dictionary by putting all the variables on the left, and on the right hand side I only have the constants. And then if you look at the coefficient matrix of these equations, that's exactly the table I have. The coefficient matrix of my dictionary is exactly the array. Okay? And again, which one do you prefer? Like I said, I actually used your book's notation of the array, worked with that throughout the semester, but I felt it is less intuitive, and that's why I'm using the new dictionary notation that I'm using? Which one do you think is easier to work with? You don't have to agree with me, but if you disagree with me, you just read the book and the way the book is working. Okay? Is everybody clear? Any questions? Any questions at all? How many of you have been reading the book? Nobody. Okay. All right. So, well, that's a good thing, because then I don't have to worry about telling you what the book is, what notation is used by the book. Did I say it's a good thing? No, it's not a good thing. Right? You should still read the book, right? Okay. Now you can read the book and understand the notation. Okay. So if you don't have, please, when you go home, think about these things. Otherwise, you might get confused at some point. By the way, most of my lectures have been at YouTube. If you want to sort of take a second look at the lectures again, because you forgot something that I said in the class, you could do that by visiting my YouTube channel. But the reason I haven't told you that yet is because, for one thing, just because I have the lectures there doesn't mean you shouldn't come to the class, because you don't get to ask me questions if you just look at the YouTube channel. The second thing is, there is no guarantee that I'm going to do it for every single lecture, because there might be a day where I'm so busy with so many things that I forgot to upload my lecture, right? And do not complain about that, because I like I'm saying, I'm not guaranteeing that's going to happen for every single lecture. But so far, I have been able to do that, and they are at my YouTube channel. If you want to see them, send me an email. I'll send you my YouTube channel address. Okay, so that's it with that. What I want to do then is move on. With all this notation, it's it's making me so slow about to talk about these things. But what I want to do now is do another example, which is not the same example that I have been using. I want to do an example where, okay, the simplex method is great, but we need to see that how does it detect when, remember, for a simplex, what are the three possibilities? The three possibilities is that my feasible region might be empty, right? That means that the problem is infeasible. I don't have any feasible solutions, right? That's one possibility, right? Second possibility is that I have a feasible region. It is a bounded region. I have an optimal solution, right? I have the second possibility, I have an optimal solution. Let me rephrase that. Second possibility, I have an optimal solution. The third possibility, I have feasible solutions, but I don't have an optimal solution. Why? Because my feasible region is unbounded, and my objective function can take on arbitrarily large values. Am I making sense? That's the third possibility. Question is, how does simplex detect unbounded problems? Am I making sense? So let's look at an example of that. Maybe I wouldn't have time to finish it. Example: maximize x1. So I should say z equals to x1. Okay, and subject to x1 minus x2 is less than or equal to 1. x1 minus x2 is larger or equal to -1. x1 comma x2 is larger or equal to 0. You might say the second inequality is greater than, well, we can make it less than or equal to, right? Everybody's okay? Multiply both sides by -1, you can make it less than or equal to. But what I want to look at now, because we don't have enough time, I just want to show you what is the feasible region. So go ahead and please do it yourself. Draw the feasible region, okay? Don't wait for me. Draw the feasible regions and see what you get. Okay, so what do you get? X1 minus X2 is equal to the first one. If I turn it into an equation, I get X1 minus, so this is my X1 axis, this is my X2 axis. So X2 is Y. X1 minus X2 is equal to 1. What is the graph of that equation? What's the graph of the equation X1 minus X2 is equal to 1? So that means X2 is equal to X1 minus 1. The slope is 1, right? So it is, let me extend this here. So let's say -1 is right here and +1 is right here. And the graph of this first equation would be okay, you agree that this is the graph of X1 minus X2 is equal to 1. Am I making sense? So when X1 is 1, you get X2 to be 0. When X1 is -1, no, I think this one corresponds to the second equation. Sorry, you guys see that? When X1 is what am I saying? Let me erase that for a second. Okay, so from the first equation, if I turn it into an equation, when X1 is 1, X2 is what? 0? You agree with that? So I get this is 1, 0. When I have the first equation, and then if I take X2 to be -1, then I get X1 is 0. So this is fine. Yeah, this is X1 minus X2 is equal to 1. Sorry, I was right the first time. And then what's the graph of the, do I need the graph below x-axis? No, because X2 is positive, right? Not negative. Okay, what's the graph of the second equation? X1 minus X2 is equal to -1, and that will be this one here. They are parallel, in fact. Parallel enough, I guess. So this would be X1 minus X2 is equal to -1. Now, what's the feasible region? Can you identify the feasible region? Can I identify the feasible region? No. Well, I'm going to let you think about this. The feasible region would be this, in between, and it is an unbounded region. Okay, make sure you understand why that's the case. Okay. Okay, so this is an unbounded region, and is it clear by our graphical method what's the optimal solution here? Well, what is my objective function here? X1. So notice that. So let's make the a level set for the objective function. So for the objective function, when is z, for example, half? Z is half. It means that X1 is half, right? This is where X1 is half, right? So this is where z is half. So this is a level set of the objective function. Remember we talked about level set. Level set means if I have the objective function set z to be a specific number, the graph of that would be the level set. So notice that I can move x1, I can move this level set along the right side, right? Along the x1 axis. I can move it always, and I always intersect the feasible region, which means that x1 increases without bound, right? Which means that the objective value increases without bound. So this is a problem where the objective function is unbounded. Now, just because I have unbounded region doesn't mean there is no optimal solution. Can you give me an example of a problem where the region, the feasible region is unbounded, but there is an optimal solution? Just look at this my example and change something. Someone please change something in my problem and make it have an optimal solution. Make it have an optimal solution. Hint, change the objective function. Change the objective function, make it have an optimal solution. What? Minimize it, or you can say maximize but put negative x1. If you do that, this problem still has an optimal solution but unbounded feasible region, right? So what I'm saying that our problem though, unbounded region and no optimal solution. And what I want to show next time, how simplex method will detect this for us. We don't have to do it graphically. You cannot do it graphically for bigger problems. So we want to know how simplex does it. Okay? So that's it. We are going to move from here